This is for the EGR 107 Catapult Challenge, Buerck Group 4's entry. The catapult is mainly constructed out of 3D printing material, 2 tongue depressors, rubber bands, and a Dixie cup. 3 key features of the design are the triangle-shaped support frame, which are where the stability and the durability of the design come from. The actual arm of the catapult is made up of the 2 tongue depressors held together and a Dixie cup at the end. And at the top and bottom of the frame, connecting the arm to the frame, are 2 rubber bands, which serve as the firing mechanism. The rubber bands, therefore, providing the tension needed to pull the arm back, and upon releasing it, will fire the projectile.
Alright, 70. Alright.
As we know, both air resistance and heat transfer were negligible for this project. The launch angle stayed the same for all gumballs, and it followed 2-dimensional motion. The potential energy was also constant. The measurements required to calculate the max distance for the 1/2-inch gumball were initial launch speed, or velocity, as it was required to determine the horizontal and vertical components of the motion and predict the distance traveled. Our average velocity was 165.41 meters per second squared. Next was launch angle. Even though it was the same for all gumballs, the 45-degree angle affects both the vertical and horizontal components of the initial velocity, which directly influences the maximum distance. Next was acceleration due to gravity. As we know, this is 9.8 meters per second squared, but gravity affects the vertical motion of the gumball, and it influences how long it stays in the air and its trajectory. Next was the diameter of the gumball, and we know that it's about 1.27 centimeters. Last was the initial height. The initial height is important in a projectile motion formula because it directly affects the starting point of the object's trajectory and alters the time it takes to reach the ground. Our initial height was the catapult at 7 inches high. We used the projectile motions formula, which was r, which is range in meters, is equal to initial velocity squared times the sine of 2 times the launch angle theta all over gravity acceleration. This gave us the max distance of 31.4994 meters on a predicted time of 0.1904 seconds.